So finally, let's learn how to make a test, also using normal distribution as approximation of proportion distribution. Okay. So in this case, you can see the question is, could population proportion be below 0.25? First of all, we can recall what proportion we had from calculations before. It's 0.196, and then n is 500. This is also the standard error that we calculated before. And now we can define a null hypothesis. And this is a tricky thing here. Look, the question is if population can be below 0.25. But the null hypothesis we said, it's that the population proportion is above or equal to 0.25. So we have to use some efforts in order to prove, for example, that null hypothesis is wrong, and then in this case we can release the medicine on public, right? So in this case we select null hypothesis which is opposite to our answer, right? And then if we can reject null hypothesis, then it will mean that it's likely that the proportion of migraines it's below 0.25, it's below quarter, right? So now we still work with confidence level 99%, so it means that our significance level is 0.01. That's what we are going to compare our p-value later. How to compute the p-value? Well, first of all, apparently you need to compute a z-score based on all these statistics and characteristics that we have. So we know the proportion of the sample, we know the proportion of the population. In this case, it's 0.25, we set it, right? So this is known, this is known, this is known, only z is not known, right? So in this case, we simply use this expression. So we take proportion of our sample minus proportion of a population and divide to the standard error. So that gives us minus 3.03. And you already understand that this is pretty extreme value, right? So it means that the proportion of our sample is pretty far away compared to the proportion of the population we have an assumption on, right? Now, which test we use? Which site we should use? Well, apparently, if you think about z-score, so these are all possible z-scores. This is 0, right? You will get 0 if proportion of your sample is the same as the proportion of your population. And then if your proportion is smaller, you will get negative values. So here we have our minus 3.03, right? And then you can see the direction that supports null hypothesis, it's a positive direction. So this is the good direction, right? And then all these directions are opposite to our null hypothesis because they kind of contradict with null hypothesis. They are more extreme if you go to the left, right? It means that the p-value is located, it's the area on the left for the z-scores that we computed, and it means that we can just use the CDF function in order to compute the p-value, and you can see that the p-value is pretty small, it's 0.001. So it's 10 times smaller than the expected significance level. Now let's check what R says. You remember that R uses not just a simple normal distribution, it uses a little bit more advanced way to approximate the distribution of proportions. And then you can see that here we still provide the number of events observed, the total number of events. And then you can see that we provide this as the population proportion we have an assumption on, 0.25. And then you can see the alternative is less, right? So we provide also, we show that it's a one-tail hypothesis and the alternative is on the left tail. So that gives us a p-value of 0.003. So the p-value is larger than what we got with using the normal distribution. But nevertheless, both in this case also we can see that the p-value is much smaller than significance level. So in this case, the outcome will be the same. We should reject null hypothesis and accept alternative hypothesis and it means that we can expect that our medicine does not lead to more than 25% of migraines for all patients who will take it, okay? Of course, if our sample is random and representative, so everything works if our sample is taken correctly, okay? And again, I have an app which shows you how this test works. So you can play a little bit. So first of all, you will watch a short video about this app and then play with this app just to check how this test works, try different tails, try different sample size and so on and so forth. And that will conclude all these videos about inference on proportion. So now you know what to do if you want to generalize the knowledge about the proportion of your sample to the proportion of population. But remember that proportion is a univariate statistic. So proportion, it's a property of one particular variable, of one particular qualitative variable. What to do if you have more than one variable? What if you want to find if there is a relationship between two variables, like we did it for with correlation and linear regression and so on and so forth. That's what the next videos will be about.